Next is example 2.19. In this, we have to find the next 3 terms of the sequences, which means we are given with a sequence and what will be the next 3 numbers. After 1 by 14, what will be the number? The number, next number, the number, next number. We have to find the next 3 numbers in this sequence as well as in this sequence. We will do one by one. So, first what we have to do is, if we can identify the sequence which is given, we can frame the next 3 terms. How to do that is, as I told you, the sequence is represented as a term, which means this is A1 first term, A2 second term, A3 third term, A4 fourth term. We have to find A5, A6 and A7 because we are asked to find next 3 terms of the sequences. So, first we will identify what is the sequence given in a format. So, first term is 1 by 2 and in the numerator all the terms occupy 1. So, always the numerator will be 1. The denominator, if you see, first term is 2 and the next term is 6. Let us apply 2 plus 4 will give me 6. But we cannot conclude within these 2 terms itself. We have to check whether this is applicable for all other terms given in the question. Let us apply and see. So, first what we did, 2 plus 4 gave me 6. Again now what I have to do is 6 plus 4, will it give the third term? Yes, it is giving 10. So, in 2 terms the concept we approached was right. And again we have to substitute, check whether it is applicable for the next term also. Yes, it is, because 10 plus 4 will give me 14. So, this is the sequence we have to follow the next term also. What should we have to do is, the sequence given is 1 by 14, we have to add 4 to the denominator. Therefore, 1 by 18. We found out the 5th term. So, with this 5th term only we can find the 6th term. What we have to do? Again we have to add 4 to the denominator. Therefore, it will give me 1 by 18 plus 4, which is 22. Only with the help of this only I can find the 7th term, which means 1 by 22. Again we have to add it with 4, which will give me 1 by 26. Thus, we have found out the 3 terms for this above sequence. Let us do the same for the second subdivision also. So, first we have to check whether what is the concept applied here, what is the sequence applied here, then we can frame the A5. Here also there are given 4 terms in the sequence, therefore we have to find A5, A6 and A7 in order to find the 3 terms of the sequences. So, first term it is 5 and the second term it is 2. So, if I apply minus 3, 5 minus 3 will give me 2. So, the minus 3 we have to apply for other terms in the sequence. Whether it is the right one, then we can apply for the all other sequences as well. So, let me apply here and see. 2 minus 3 plus 2 minus 3 will give me minus 1. Yes, it is applicable for the next 2 terms as well. Next, we will check for the other 2 terms. Minus 1, minus 3. Minus 1 minus 3 will give me minus 4. Yes, it is the right one. Thus, we have found out the sequence for the above one. Therefore, we can easily find out A5, A6 and A7. So, now the term is minus 4. According to the sequence, we have to include minus 3. So, what it will give me? Minus 4, minus 3, minus 7. Again, we got the 5th term. We have to use minus 3 to find out A6. So, minus 7 minus 3 will give me minus 10. So, now with the help of A6 only we can find A7. So, minus 10, according to the sequence we have to include minus 3. Therefore, it will give me minus 10, minus 3, minus 13. Thus, we have found out the 3 terms of the sequences. So, in the next subdivision we are given with the first 3 terms, that is 1, 0.1, 0.01. First, we have to find the sequence which is followed in this, then only we can frame the next 3 terms. Here we are given with 3 terms, therefore we have to find A4. According to the question, we have to find 3 terms. Therefore, A4 we have to find, A5 we have to find and A6 as well we have to find. So, first to find all these 3 terms, we must know what is the sequence used here. So, what is the connection between 1 and 0.1? 1 when it is divided by 10 will give us 0.1. Okay, so we have assumed some concept between these 2 terms. We have to apply for the next term and see whether this is the right one. 0.1 when it is divided by 10, obviously it will give me 0.01. So we have got the right sequence. Now what will we have to do is 0.01 divided by 10. What it will give? 0.001. So this is the fourth term. To find the fifth term, the fourth term must be divided by 10. So 0.001 by 10, which will give me 0.0001. And using this term, we can find the sixth term, 0.0001. When it is divided by 10, the 10 after the decimal will be increased. Therefore, it will give me 0.00001. Thus, we have found out the three terms in the sequence given in the question. Example 2.20. Now what we have to do in this problem is we have to find the general term. That is general term in the sense we have to find an for the following sequences. We will do one by one. So the first sequence here it is given as 3, 6, 9. We can write directly the nth term also. If we know to write, we can directly write, but I prefer the method of choosing arithmetic progression to write the nth term. And also I told you the arithmetic progression can only be used if the common difference between any two terms is the same. Then only we can prefer the arithmetic progression method. So the common difference between these terms are all the same, which means the common difference between these first two terms are 3 and the next two terms are also 3. So it is same. I am going to prefer AP method. AP is A plus n minus 1 into D. In this, A represents the first term in the sequence and D represents the common difference between any two terms of the sequence, which is 3. So let us apply here and find the nth term. 3 plus n minus 1 into D. D value is also 3. So therefore 3 plus 3n minus 3. 3 and 3 will get cancelled. 3n. So an for this problem is 3n, where n varies from 1, 2, 3, etc. It goes on. Let us check also. If I apply the n value as 1, a1 is equals to 3 into 1, 3. I got the first term. Next, if I apply n value as 2, a2 as 3 into 2, 6. Second term. So this is the right format of the general term for the sequence. Second, we have to write the an for the above sequence. What we have to do is, if you see in the numerator also we have to find the nth term, and for the denominator also we have to find the nth term. We will do one by one. For the numerator, the sequence is given as 1, 2, 3, etc. It goes on. We are going to use the same formula, a plus n minus 1 into d. A value in this sequence is 1 and d value in this sequence is as well 1, because the common difference between any two terms is 1. So a value plus n minus 1 into d value is also 1. 1 plus n minus 1. This and this will get cancelled. Numerator will be n. Similarly, we will do the same format for the denominator as well. Denominator holds the sequence 2, 3, 4. Now we have to write the a value, that is a value is 2 first term and the common difference between any two terms is 1. Therefore, d value is 1. We have to substitute in the arithmetic progression formula. A plus n minus 1 into d value is 1. We have to simplify this. 2 plus 1 n minus 1. So n plus 1. n 2 minus 1 is 1. So the denominator is n plus 1 and n value varies from 1, 2, 3 as well, it goes on. So we will see whether this is the right one for the above sequence. If I take the value of n as 1, what will I get? a1 is equals to 1 by 1 plus 1, which is 1 by 2. We got the first term of the sequence. If I take the value of n as 2 and apply here, a2 equals to 2 by 2 plus 1, 2 by 3. So 2 by 3 is the second term. So this is the general term for the above sequence given. Thus we have found. And we have to find the an for the third subdivision. But whereas here we cannot use the arithmetic progression formula, because the common difference between the two terms are not the same. So we have to write it in general. Let us see how to write it in general. If first we have to find what concept is used between any two numbers. So what is this, how is the sequence framed, we have to find, then only we can write the nth term. Also the alternative number is in minus, plus the next number in the sequence will be in minus. So alternative terms is minus. And what is the connection between 5 and 25? We can easily find out. First 5, next number it is given as 25. So 5 square will give us 25. Next the third term, is it applicable, the same is applicable, we have to check. We used 5 square. If I take 5 cube, it is 125. Therefore it is in terms of powers of 5. So we can write it as 5 power n. Whether only 5 power n is enough for the above sequence? No, it is not. Why it is not is, we have minus in the alternative. So minus 1 power n plus 1. So this is the an general term for the above sequence. Why am I saying so is, n value obviously it varies from 1, 2, 3, it goes on. See, if I take the value of n as 1 and apply in this, will give me a1 is equals to minus 1 power 1 plus 1, 5 power 1. So minus 1, here it is squared. So minus 1 into minus 1 will give me plus 1 into 5, 5. So first term. So similarly, I will do it for the second term. I will consider the value of n as 2. Therefore, a2 equals to minus 1 power n value is 2. 2 plus 1, 5 squared. Now if you see, minus 1 power 3, 2 plus 1 is 3. When it is cube, minus will stay. That is when it is odd number, the power, if it is an odd number, the minus will stay. Therefore minus 5 square is 25. So thus we got the second sequence. So thus we have found the nth term for the above sequence given. So next is example 2.21. The general term of a sequence is defined as, they gave the general term, an is n into n plus 3 when n is an odd number, and an, that is general term, is n square plus 1 when n is an even number. So they gave two an's values when n is odd and when n is even. We have to find the 11th and the 18th terms. So this is very easy to do. Let us find one by one. Now first we are asked to find the 11th term, and how do we represent the 11th term? A11. So according to the question, when n is odd we have to use this an value, and when n is even we have to use the an value of this. So now A11, n is odd, that is 11 is an odd number, therefore we have to use the general term an is equals to n into n plus 3. So n value, that is we have to find the 11th term, n is equals to 11, A11 equals to 11 into 11 plus 3, 11 into 11 plus 3 is 14. So 14 into 11, which is 154. Therefore, A11 is 154. Next, we have to find the 18th term, which can be represented as A18. If n is an even number, we have to use the an value as an is equals to n square plus 1. Let us take it so, because n is an even number. So an is equals to n square plus 1. Now we have to find the 18th term. N value is 18, which is an even number. Therefore, we should use the value of an as an is equals to n square plus 1, and n value is given as 18 to find. Therefore, substituting in this, A18 is equals to 18 square plus 1. 18 square it is 18 into 18, 8 8s are 64, 6 balance, 8 1s are 8 plus 6 it is 14, 8 1, simplifying 324. Therefore, 324 plus 1, which is 325. Therefore, 18th term is 325 according to the given general term of a sequence. Thus, we have found out the 11th term and the 18th term in this problem. Next is example 2.22. What we have to do is we have to find the first 5 terms of the following sequence. To find the first 5 terms, first term is given, second term is given. We need to find the third term, fourth term, fifth term. To find out the 3 terms, we are given with the general term an, which means we have to take the value of n from 3 greater than or equal to 3 and n is a natural number. So, to find the first 5 terms, we can use the n values as 3, 4, 5 because first 2 terms is already given. Let us find using the first 2 terms the next 3 terms. So, given an is equals to a n minus 1 by a n minus 2 plus 3. First we have to find a3, which means we have to take the value of n as 3. First 2 terms is given, we need to find the third term a3. So therefore we have to substitute the values of n all over as 3. So a3 minus 1 by a3 minus 2 plus 3. So which was a3 minus 1 is 2 by 3 minus 2 is a1 plus 3. We already are given with the values of a1 and a2. We can substitute here. a2 value is given as 1 and a1 value is also given as 1. Substituting it here, we are getting 1 by 1 plus 3, it is 4. Therefore, a3, that is third term in the sequence is 1 by 4. Now, with the help of a1, a2 and a3, we can find the fourth term a4 using the same general term of the sequence an. So, we have to substitute the value of n is equals to 4 now. Therefore, a4 is equals to n value is 4. So, therefore, 4 minus 1 a 4 minus 2 plus 3. 4 minus 1 it is 3 by 4 minus 2 it is 2 plus 3. We know the value of a3 which we found as 1 by 4 divided by a1 value, a2 value it is given as 1 plus 3. Therefore, 1 by 4 by 4. So, if we reciprocate this, it will become 1 by 4 because it is like 4 by 1. So, 1 by 4, if I reciprocate this, I will get 1 by 4 which will give me 1 by 16. Therefore, a4 is equals to 1 by 16. So, with this we can find out the fifth term by substituting n is equals to 5 in the general sequence. So, n is equals to 5 if I substitute. So, I will get a5 equals to a5 minus 1 by a5 minus 2 plus 3. So, a4 by a3 plus 3. We know the value of a4 is 1 by 16. Substituting it by a3 value is 1 by 4 plus 3. So, first we will complete the denominator portion. It will become 1 by 16 by 4 3s are 12. Therefore, taking LCM 1 plus 12 divided by 4 and simplifying this 1 by 16. This we can reciprocate. It will become 4 by 1 plus 12 it is 13. Cancelling this it will give me 4. 13 into 4 is 52. Therefore, fifth term in the sequence is 1 by 52.